Lesson 7.3, Graphing Quadratic Functions. Just as we could graph linear equations, we can also graph quadratic equations. And there are two methods. Method 1 is a t-table, and method 2 is using the vertex and the line of symmetry. Now, in our last lesson, we discussed that the line of symmetry is the line that cuts the parabola in half. So if I have some random parabola, the line of symmetry will run down the center of the parabola, like this. And the vertex is the point where the curve occurs. So vertex, line of symmetry. Now, graphing quadratic functions are always a parabola. So we'll know that that's the shape that we should be receiving. So we're going to try to graph some quadratic functions using both the vertex and the line of symmetry so that we can compare the methods. For our first example, we're going to graph the equation y equals negative x squared plus 2x plus 1. Method 1 will be to use a table, and method 2 will be the vertex and the line of symmetry. So first, I need to go ahead and make a coordinate plane. I'll make another one over here. Okay. Using a table, I'm making a table of x and y values. And what I'll do is I'll plug those in. So let me just grab some scratch paper for the calculations. Okay, so I usually start with 0. So if I have a 0 for my x, I'll plug it in. I get negative 0 squared plus 2 times 0 plus 1. So y is equal to 1. And then I move in the positive direction until I find that I'm basically what's happening, I need to find this shape. So if I move and I'm finding points that keep doing this, I need to go in the opposite direction to find this, and I need to find that curve. So if I plug in a 1 for x, I get negative 1 plus 2 plus 1, so that's 2. If I plug in a 2 for x, I get negative 4 plus 1, so that equals 1. And here is an interesting thing that has happened. As you can see, my y values are 1 and 1. If I were to graph this now, I have 0, 1, 1, 2, 2, 1. I know from my previous experience that because I have a negative x squared, my parabola is going to curve down, and I found the curve. So I'm going to go 1 point each direction just to get the width good. So I'm going to do a negative 1 and a positive 3. So I get y is equal to negative of negative 1 squared plus 2 times negative 1 plus 1. That gives me negative 1 minus 2 plus 1. So that's negative 2. And since parabolas are symmetric, my 3 should also give me a negative 2. So I have negative 9 plus 6 plus 1. That equals negative 2. So here are my points. And the parabola is a curve, so you don't make a straight pointy line here, you curve around and come down like this. Now sometimes it can take longer to find that curve, and that's when the axis of symmetry comes in handy. Now with an axis of symmetry, we want to find the vertex, we want to find the y-intercept, and we want to find the axis of symmetry. Okay, so to find the y-intercept, we plug in x for 0, 0 for x. To find the vertex, we first find the axis of symmetry. Now the axis of symmetry has an equation. That's negative b over 2a. And you may recognize this from part of the quadratic formula. You have negative b and then plus or minus the square root of b squared all over 2a. And that's where this comes from, the vertex. Comes from, sorry, the axis of symmetry comes from the quadratic formula. So for my particular equation, I'll use these. After I found the axis of symmetry, I plug in this value as x and solve for y, and that will give me my vertex xy. Okay, so first we're going to find our y-intercept. We plug in 0 for x to find our y-intercept, so we get 1. So I plot that on the graph. Then I find my axis of symmetry. Again, that's negative b over 2a. b is 2, so I have negative 2 over 2 times negative 1. That's negative 2 over negative 2, so that's positive 1. My axis of symmetry is a vertical line on that value of x. So I make a vertical line on 1. And then to find my vertex, I plug in 1 for x. So I get negative 1 squared plus 2 times 1 plus 1. So that's negative 1 plus 2 plus 1, so that's 2. So my vertex is occurring at the point 1, 2. 1, 2. And then finally, a parabola is symmetrical. So I move the same number of spaces from the y-intercept, and I make another dot. Now I have my curve, and I can graph my parabola. So let's try another example using both methods. That one's not pretty. Okay, so for our next example, we'll graph y is equal to 2x squared minus 16x plus 33. Okay, for my first example, I'm going to use a table of xy values. Okay, so I'm going to plug in 0 for x, and I'm going to get 33 for y. Now I'm going to need a lot of space here, so we'll have to probably shift the graph up and down. If I plug in 1 for x, I will get 2 times 1 squared minus 16 times 1 plus 33. That's 2 minus 16 plus 33. Which is 19. So I can tell you right now I'm kind of going down as I go across. So I'll plug in 2, and I get 2 times 2 squared minus 16 times 2 plus 33. So that's 2 times 4 is 8, minus 32 plus 33. So that's 9. Oh, I should point out, this is positive, so my parabola needs to go like this. And right now I've got points going down. So I haven't hit my curve yet, so I need to keep going in the positive direction. Sorry about that. So I'll plug in a 3, and I have 2 times 3 squared minus 16 times 3 plus 33. That's 2 times 9, which is 18. 16 times 3 is 48. So I have 18 minus 48 plus 33, which gives me a 3. So I need to keep going until I get that curve to go back up. So I'll plug in a 4. So 2 times 16 is 32 minus 64 plus 33. So 32 minus 64 plus 33 is 1. So I plug in a 5. So I have 2 times 25 is 50 minus 16 times 5 is 80 plus 33. So 50 minus 80 plus 33 is 3. I finally found my curve. So now I need to graph this, and because the 33 is actually so high and my curve is occurring here, I'm going to actually graph the smaller numbers. So what I'll do is I'll start here with my x-axis, and I'm going to put my y-axis over here because I'm not using any negatives. 0 is 33, that's way up here. 1 is 19, also way up here, but 2 is 9, which takes me here. 3, 3, 4, 1, 5, 3. Now if I kept going, parabolas are symmetric, so I'll hit 9 again. Now this is a nice skinny parabola, like that. Now as you saw, I had to find a lot of points to find that curve. If I use the vertex and the axis of symmetry, I'll spare myself from having to do this much mathematical calculations. So let's try that now. Same problem. Y is equal to 2x squared minus 16x plus 33. I'm going to go ahead and create my graph. Now normally, oops, that's a little over. Normally I wouldn't even draw this until I had my vertex, but since I know what it's going to look like, I'm going to go ahead and do this. Now my y-intercept is 33. That might be a little bit of a difficulty with the way I drew my graph, so I'm probably going to have to actually change this. My axis of symmetry is going to be negative b over 2a. So I'm going to have negative 16 over 2 times 2. So that's positive 16 over 4. So that's 4. So I'm going to draw my axis of symmetry on 4. That's right here. And then to find my vertex, I'm going to plug in x, which is 4, and I get 2 times 4 squared minus 16 times 4 plus 33, and that's going to give me a 1. So my vertex is 4, 1. Now, because my y-intercept is 33 and it's so far over, something that you can do to avoid having to make your graph that tall is try to find closer points. You can plug in 2 or 3, 5 or 6. So I'm going to just plug in 2. And when I plug in 2, I get 2 times 2 squared minus 16 times 2 plus 33. So that's 8 minus 32 plus 33, which gave me 9. So 2 is 9. And again, because I'm symmetric, if I'm 2 spaces wide here, I go 2 spaces over, plot my point, and draw my parabola. And that's how you graph a quadratic equation.